Ethan, yep, 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 yep. Kyle, yep. Gavin, okay, yep, yep. I don't know. Reactions down at the bottom?
Yep.
Oh, we lost
The
everybody.
reactions button, you can have smiley faces and such.
Will is round of applauding. Okay. Are you here today? Ready? 1, 2, 3. Are you here today? Yes. 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 Kyle, come on. Come on, Kyle. Where's he at? Oh, he went to the bathroom. Come on, Kyle. All right. Well, good morning, everybody. Thanks for showing up. I don't think everybody's here today, but we're recording this the same way Steve was yesterday. So my name is Zach, and the other fella in the other lab is Tom. So the initial idea here is that I'm going to be in here with you guys, and he's going to be in there with them, and we're going to communicate back and forth via Zoom. And whether it's a designed lab with the schematic that we give to you guys, or we're doing a demonstration, one of us will be able to do it on the camera so you guys can see it. And then you guys will have your parts kits. Oh, I talked to them. Does anybody in here not have tools and parts kits yet? It's okay if you don't. Okay.
Everybody have their tools and parts kits?
Okay, I tell you what I'm going to do. I'm going to that mass email that I sent out, like with the Zoom link and everything this morning and telling you guys to come in this morning, I'm going to send out a tool list to everybody so everybody has the same one. And since, yes. What if you already like ordered them from the bookstore and everything? Oh, you're fine. You're fine. Yeah. Let me actually pull that up for you guys to see. I gotta find it first. So this is the file that I'm going to be sending you guys in an email, but a lot of these things you guys probably already have. So you're not required to get these brands. Like if you have screwdrivers already, fine. The important things are, especially off the bat, this electronics parts kit down at the bottom. You're only going to find that at the bookstore. And what it is a bunch of little capacitors and resistors and stuff, and it comes in a little brown box. We're going to use that quite a bit your first year. I could give you a list of all the parts and you could part them out online if you want to try to find something cheaper, but it would be probably the exact same cost, maybe even cheaper at the bookstore, and it's all put together for you. So I think it's like 20 bucks, 25 bucks or something like that. The other thing is the digital multimeter. So the instructors have Fluke 117. I don't know if you can still see my camera yet, but this is the Fluke 117. Really good meter. It's not cheap, but you can use this thing the rest of your life. And on the job, when you guys get out of here and you all get really good high-paying jobs, that's a good meter for you. You don't have to get that one. Or if you want to get this one online to see if you can get cheaper from the books, then the bookstore carries it. Whatever meter you get, it needs to be category 3 to 600 volts. It has to say that on there somewhere.
Yeah, you should have a rating on there. It should say like a Cat 3 and Cat 4. And there should be like a really good ones have both Cat 3 and 4. So it'll be 2 voltage ratings on it. That means it's not going to blow up in your hands when you put it across something.
Yeah, which is important. And it's not that we want you guys to spend a bunch of money just to be here, but I mean, I have a free, at Harbor Freight, when you buy something, you get a free meter. Well, I have that at home, but I don't trust my life to it. You know what I mean? So, and this is really, really good meter. The other thing with that is if you get a different type of meter, like let's say an Ideal that's pretty similar to that, and it says category 3 to 600 volts, that's fine. But we as instructors, we're not expecting the staff here to be experts on 57 different types of meters. So it's probably very similar to this, but you're kind of on your own as far as knowing how to use the functions on it. Does that make sense? And not that we won't help you, but we're not walking human meter manuals. You know what I'm saying? So those are the two things that I always point out to everybody. Safety glasses. You might even have some of those already. Your first year, what you're going to use the most of are parts kits, strippers, definitely your meter and your parts kits, screwdrivers. Everything else is just for, having fun. Just kidding. What am I talking about, Tom? Whoa, somebody's got a camera on.
Yeah, they do.
Who's that?
Oh, using your phone? Yeah, he's doing it on his cell phone. He couldn't log into the system. There's something wrong with his password. I told him to get a hold of IT. So he's able to follow the link through his email.
All right, I mean, I can hear it right now.
Okay.
Oh.
All right. Well, see one of us after class. You weren't able to log onto your computer?
Yeah, everybody else is logged in, right?
Okay.
Yeah, he's the only one.
All right, we'll get you figured out. Okay. Capital ICC in the last 5. So I'm assuming you tried that and it's not working. So maybe you changed your password at some point and just don't know what it was. Anyway, we'll figure it out. They can reset it if nothing else.
Okay.
Okay, now I realize that the schedule is kind of jacked up. So the schedule that you have for these classes is not, you're taking ELCTS 131 and 132, all of you, except there might be one student who's only taking 132. But this today is the new setup. And that email that I sent out to all of you guys yesterday, that's what we're going to go with, that schedule. So plan on for the near future, at least, being at home, online, and Zoom with Steve on Mondays and Wednesdays, and being here in your designated lab space on Tuesdays and Thursdays, right? And what we've done in the past with 131 and 132 is split up different sections of chapters of the same book. And I think it's like the first 9 or 10 chapters in that Frenzel book. Does everybody have a textbook? Anybody not have a textbook?
Awesome.
Okay.
Yep.
All right. So instead of doing it the old way with this COVID business and everybody's got weird schedules, we decided, well, let's just group everybody together, do all the online stuff together, do all the labs on the same days so there's no confusion. And we've all this set up, and I'm pointing to my room, 109. All this equipment used to be over there. We split it up so we could keep everybody 6 feet apart. So I think it's going to work out just fine. And then you're going to have basically two instructors for labs walking you through everything too. So I think it's going to work out well. But does anybody have any questions about the schedule? Any concerns with anything that goes for either room? Out here at what? That's a good question. Okay, so question in here was, are we going to be leaving here at noon every day? My answer for you is no. And I don't, since the schedules of the two classes were a little bit different, I don't remember which is which, but we had to kind of meet in that common area of 9 to noon for everybody. So usually when I have this class by myself, we do a little bit of lecture every day, and then there's some lab work every day. And when you get your lab done, take off, you know? So it just depends on when we get done with that day's material. Okay, so if it takes you all the way till noon, fine. If it takes you a half an hour, so be it. But everybody just needs to be on the same page. Was there a question from the other room?
Oh, he was just asking about the Monday and Wednesday Zoom meetings
Okay.
and how that's, and I told him, it's like, well, the great thing about Zoom, because we can record it, so if you can't make it on that time, at that time frame for whatever emergency or whatnot, we record these sessions so you can still look at it later, but you should contact the instructor and let them know that you're not going to attend that day. So, because we do use that for attendance, and that way you don't get marked like absent or something like that.
Yeah.
Does that make sense?
Yeah, and I would just say, do your best to be on the online ones, because as an instructor, I need feedback and I need people to tell me I get it and I don't. And if most of the class is not showing up and then I get 10 emails later that day saying, hey, can you explain this more? It's like, man, like come in when we're all together and we can do it together as a group instead of piecemeal. So he's back. You missed so much. It's all done. Just kidding. That's Mr. Brown.
Ooh, I like that.
Okay, what's next? Any questions so far? Okay.
No question?
Did anybody try to open the YouTube video that was put on Blackboard yesterday from, let's see.
Yeah, so when you log in on the Blackboard site, there should have been like a YouTube video, like, the link, and then it automatically goes, we're pretty much right on the YouTube application, and it should have been his whole lecture. Because that's a great thing about Zoom, because what we do is we record it, and then there's, I won't go into it, but basically we end up uploading it on our own. I have my own channel on YouTube now, which I never had before, and so you can actually even just go right on, like Steve will have his own YouTube channel if you want to favorite it or something like that, and just go right in there, and you can usually see like his whole lectures for the class and stuff. So you can always go back, which is nice too. So if you wanted to go over some points maybe from like last Wednesday's Zoom lecture or something like that, it does allow you to do that, which is really nice. Sorry.
Okay, so real quick. Still haven't taken attendance. Oh my crap. Okay, my room, Harrison. What? Scream it. Here, all right. And when I call your name, I need to see a heart emoji. A heart emoji on the thing. You missed it because you were taking a dump. Harrison's here. Okay, what am I doing? Okay, Gavin, Caden, Kyle, Tegan, Ashley, Matthew. All right, and in the room 108, since I can't hear you guys very well, I need you to go to like this when I call your name. Are you ready? Caw-caw, caw-caw, caw-caw.
Just like that? I gotta hear this.
You ready? Cody. Ethan. Peyton. Oh, you're okay. It doesn't matter. You're fine. So Peyton's over here. Drew. Nathaniel.
Oh, you're killing me.
Eli,
He's here.
he is.
Yeah, he didn't do the cacao though. Oh no, is that point soft in the day?
Carter, DeRay, and Will. Yeah, that's what I'm talking about.
Oh,
Okay. We're doing that every day, by the way, because I love it. Okay. So I tried to find that this guy yesterday Steve put on there, and I was unable to get to that video. So I popped in and saw a schematic of what he was talking about. But what did you guys? Oh, wait a minute. Okay. So the people that were in the original Tom section, you will at some point have a video to watch on YouTube. It's this one that I can't get to. I should turn that off because that's confusing. But you can see my screen, right? My mouse. Okay. If you were not in Steve's lecture yesterday, you will have a video to watch to get caught up on. So just keep an eye on your Blackboard and your email. I was unable to watch it, so I don't know what I should cover today. My plan today was just to go over your lab equipment and start playing around with it a little bit. So what did you guys go over? For those of you who might have been most of you next door, were you guys, did you go over Ohm's law? A little bit. Teaser? Ohm's law teaser? Okay. Well, I tell you what, let's look at our power supply and our meters. If you've got your digital multimeter, we'll just plug some things in, check some voltages, and today we'll just talk about voltage, and that'll be it. Since most of you don't have your digital multimeters or your parts kits yet, let's try to get those before Thursday. I'm gonna write myself a note to send you guys the tool.
oh, right. Yeah. You guys know what? Number one.
You know what? Before we play around with our equipment, I want to do one more thing, because this is how I'm going to post the YouTube videos from these labs. Anybody in the room familiar with Google Drive? Okay, so whether or not you know it, you have a Google account associated with your ICC account. It's your atlab.icc.edu account. And with that, this is a little secret that I'm letting you in on. With that Google Drive account, you have unlimited storage, unlimited data. So I use Google Drive for everything. If you can't tell, here's my drive. I use it for everything. But I want everybody to walk through logging into Google Drive right now while we're all together. So your username, you should have your username, right? Because you all logged into your computer with it. So if you go to, just go to Google, search for Google Drive. Click that first link and it should make you sign in. I'm not going to have to sign in because I'm already signed in. But once you do that, underneath, when you're signed into your drive, on the left-hand side, underneath my drive, you should see something that says shared with me. And pretty soon here, I'm going to share a folder with you so you can all see it. I'm just to
black, red and black.
Great.
So each of these is an individual box. Now, two of those are very, so that means I can change the voltage, I can change the current to pretty much whatever I want within the limits of the device. I'm not gonna get like 1,000 volt out. But that's pretty versatile. And then the very end one, if you look, it's actually a fixed 5 volt power supply. And the reason being is this one, so the 5 volt, this one actually can deliver more at that voltage, so which is very, very common within like electronics, whatnot, for a 5 volt supply. But the two in the middle here are allowed to be changed. You can pretty much set what the voltage is, and pretty much set what the current is. Now, what you would want to do is have it hooked up whatever circuit you have to it, or, as you adjust it and whatnot. When you put it in the visible, current reading, current's gotta have somewhere to go, so if it's just sitting there and not hooked up to anything, that's how much current you'll have. But it's not got anywhere to go. That's the biggest thing, but, so these two, the meter and the power supply, these two will be used in most cases. We'll get you familiarized with them, get you used to playing with them. And then the first kit, but they'll have, like Zach was saying, we have like a bunch of, there's a bunch of different components for the labs. And then one of the most important things, I got these guys, is a solderless breadboard, okay? So we don't have to put any solder into it. The nice thing about these is you can take these, so you'll probably within your first kit, you'll have one of these, and then it gets bigger as you go around. But in the beginning, you're gonna do simple circuits.
Okay.
And
Can y'all hear me? Next door. Can you hear me?
Equal to voltage and current. And what this means is power. Now you guys can see this. Anybody ever heard of watt?
All right. I'm going to take all of you and share this folder with you. So if you miss a lab or something, you need to come and these ones here. All right, now underneath my drive and you go to shared with me, you should have a folder there that says ElectS 131 and 132. Is that right? Okay. All right. Thumbs up. Like it. All right. Well, I don't know what So the force behind the water being pushed through the pipes is, that's your voltage. It's the force. If you can imagine a pump being bigger, it's going to be bigger force. So if you are the water wheel providing resistance to some kind of circuit and in resistance to current flow, and you have a certain amount of resistance, a bigger voltage is going to push more current through you, right? So you can't have current without voltage, but you can have voltage without current. How could you have voltage without current in this water circuit? Any ideas? What if I cut the pipe right here? You've still got a pump. You've still got that force, and the water's probably just spewing out of the pipe, but there's no current flowing in this circuit, right? So you can have voltage without current. You can't have current without voltage. Okay, you can have water sitting there with no current flow because you don't have any voltage, but you can't have current without voltage. That's what I wanted to get across to you, because somewhere down the road you're going to have maybe a question like that on a quiz or homework or something. Just saying, not saying, just saying. But today we're just going to look at E. E is the voltage. So if we provide more force to a circuit, then and the resistance stays the same, you will get more current. So on your meters, actually I need to plug this bad boy. And really all I want to do today is get you guys familiar with your equipment. How do I? Here we go. Oh yeah, look at that. So can I flip? No, I can't. I can do this though. Whoop, whoop. Say hi. You got chosen to be the one I zoom in on. I just want to see how good the zoom is on this thing. Oh yeah. Oh yeah, that's really good.
Look how handsome that face is.
Look at that. Hey. All right. Not screwing around. So you guys have some leads in front of you. You may or may not have this, but all I'm going to do is turn this as the power supply. It's a DC power supply, and it will supply. Anybody know what DC stands for? Direct current. So current is going to flow from one direction to the other only. Okay. When you guys get into 133, the second 8 weeks, then you start talking about alternating current. You may see it in these classes a little bit. We might talk about it, but for now, for the sake of 131 and 132, we're going to deal mostly with direct current, which is what this thing is going to provide. So on your water wheel, where did that go? On your water wheel, current's going to flow in one direction through that wheel, right? It's not going to go back and forth 60 times a second. That's alternating current. But we're going to provide a difference of charge, a difference of potential from the positive to the negative in one direction only, okay? Do you understand what I mean by difference of potential? Because you'll hear that a lot. Let's talk about that really quick, because it's important. Have you ever noticed everybody's seen power lines, right? Why can I not open this up? Oh, there you are. Can you see my screen? Can you see the water thing? Yeah? Okay. You've all seen power lines, right? Got a pole with a thing across there, and there's usually 3 sets of lines up top. And that's really good drawing. How do you like my art abilities so far? Good? Okay, just checking. And then you're gonna have one down below it. That's the neutral. Okay, so you'll talk about 3-phase power, but in this class we're not so much already. Difference of potential. So have you ever seen a bird? Oh, this is gonna be really good. Whoa, yeah. Oh, bird. That's terrible. Sitting on these things. Yeah. Okay, these power lines are thousands and thousands of volts. At minimum, the lower, like residential ones, I think are somewhere around 4,000 volts on one phase. And he's sitting on there. How is that possible? He's not grounded. So what does that mean? There's no current can't flow. The circuit's not, well, but is there a circuit? I mean, if let's say this is DC and not AC, but for this purpose, we're flowing in that direction, 4,000 volts. Why does it not choose to go up his leg through his man bird parts and back out the other leg? Why? Yes and no. And a lot of people say that electricity or current takes the path of least resistance. But if that's the case, all of these lights are in parallel, right? Which means you got a hot and a neutral for the sake of simplicity. If these lights in a row are all in the same circuit, and they're going from here down to the end, and they all have their return path. So current can go through the first light, come back. Current can go through the second light, come back, right? Alternating current in that circuit. What's keeping it from finding the least resistive path and only going to that one? It doesn't. The difference between that and this bird is that this side, the neutral side, that return path is ground. It's a really good return path. On that bird, it's not. So yes, to answer your question, that's a good answer, but yes and no. You won't get any current flow up his leg because there's no difference of potential there. Now, if one of his legs was down here touching the neutral, that's a really good return path, and that's bye-bye bird. It would explode probably. But there's no difference of potential from one leg to the other. And you might remember from like high school classes, I don't know if you took physics but potential versus kinetic energy, does that sound familiar? So if I have a hill and there's a big boulder up here and it's just sitting there, is that potential energy or is that kinetic energy?
No, it's potential.
It's potential because there's no motion. It's just sitting there. If that ball starts rolling down the hill, that's kinetic energy. That's energy happening. So when it comes to voltage and there's a difference of potential, that's like saying if this bird is connected to, let's say, a 9-volt battery, so there's +9 and there's common over here, that's a pretty small hill, right? Maybe something like that. So if this resistance is low, it's not even going to flow through it. And this is probably all confusing, but the more you work with it, the more it will make sense. If we're gonna use power supply for voltage, I'd like to understand what the point is. A bigger difference of potential is, let's say this is +4,000 volts, right? And this is common. That's a hill that looks like that, right? So here's one, there's another. It's a bigger difference of potential, right? From this leg to this leg, there's basically zero difference of potential. That's why no current flows through that bird. But if I took and broke the line right here between his legs, he'd get smoked, right? But I've always found that kind of fascinating, that that's thousands of volts up there and those birds just go and they're just sitting on it, you know, nothing, kind of crazy. But every once in a while, you ever have your power flicker or it goes off and comes back on like 3 times in a row? There's these reset, I don't remember what they are, but every once in a while a squirrel or something will be on one of these lines and they'll touch something that's at the pole. So they'll touch the cross brace or something else and they'll short out basically that line, and it's set to reset 3 times to clear that animal or tree branch or whatever and try to come back on by itself. But anyway, just throwing that out there. So last thing I'll do is you guys can go ahead and plug and chug with your power supply. So this is the power supply. This is what we're going to use to provide voltage. This one can also provide a set amount of current, but we're not going to worry about that right now. And then the unit above mine, yours might be different, but it says SDM 3055 digital multimeter. So you have a function generator up here that's used to provide alternating current waveforms. We're not going to use that right now. We're just going to use the digital multimeter and the power supply. And then I'm just going to set, and also, Tom, are you over there listening? Caw-caw, caw-caw! Oh, yeah. So you guys have a bunch of leads in front of you. I would take, let's see, do you have some with little alligator clips like this? These little micro grabbers. I would plug those into your, let's plug those into your power supply. And I'm gonna go to channel 1. And I guess my video is backwards, isn't it? Hang on, I can fix that. I can fix that. I can fix it. There we go. There we go. Caw-caw, caw-caw, caw-caw! The Mexican yodel. Tom, you're muted. You're still muted. All I see is a dog that says 6 feet people. So anyway, Kyle says you should respond to my caw with the Mexican yodel. There we go. Hey, here we go. That's pretty good. That's pretty good, Tom. All right, so I'm plugging in these micro grabbers to the power supply. And just so you, hello? Oh, you're good. Oh, okay. Oh, is that right? We're playing with power supplies right now. Yeah, no worries. All right, man. See ya. You have 2 sets of meter leads, so you need the little micro grabbers. I need another set too. Does anybody need any extra leads? Most of our stuff is going to be next door. So actually, let's steal some from other people's stuff. You need micro grabbers? A little. You got those. You have these. Should be good. You got one of each of these. You should be good. Anybody else need something? Yeah, I would put the pokers, put these in your meter, and put the little micro grabbers that have the spring-loaded hooks on them. Put those in your power supply. And then if you've got your own digital multimeter with you, you can pull that out. All we're going to do is play around with channel 1, channel 2, turn voltages up and down, and that's it. I just want you to be familiar with how to turn them on and off. So what I'm going to do is I guess I'll try to read voltage. Channel 1 is on. I'm going to turn the voltage up. Say what?
I can't get my power supply from it.
You won't turn on at all?
No.
Crazy. Good. Yep. So you get a little slap and tickle. Tom, come here. Oh, like walk over here. Have you used these power supplies very much?
Pardon?
Have you used these power supplies very much?
Yeah, they're finicky. Oh, got the overload. You know why? Watch this. Isn't that amazing? Every time.
So how do you reset it?
All I did, and I swear to God, you just give it a little bump and then it adjusts. But otherwise,
Huh.
Isn't that crazy?
Okay.
Yeah, I've been getting the dragged over the coals with these power sports.
Yeah, no kidding. Right. What?
Oh, they let you get.
Oh, yeah.
Oh, hey, hi Kyle, how are
Doing
you?
good, Tom. How about you?
I'm doing well. It's good to see you back. You skip a semester? We're gonna do this though? We're gonna do it? Awesome. Come on, man. This is where the money's at.
It is.
And this is the best time. The automation's coming now. You guys are gonna get in there and I mean, it's gonna be so fantastic. Industry's changing. They got, actually they're duking it out there right now. Whose standards are gonna be the top dog in automation? And we'll see which one comes out, but yeah, that's gonna be crazy. If you really wanna go crazy with the electrical technician thing, I recommend getting heavily involved with like PLCs, automation, and robotics. But that's just my own personal bias. I'm glad to see you, Kyle.
Great.
I'd seen your name and I'm thinking, no, it's gotta be a different guy. No, it's the same guy.
Yeah,
Oh, good, good. I'm glad you're back.
I'm glad to see you too. So, I still remember getting shocked in here, like anytime when I had one of the guys that saw you, here, touch that. Yeah, that's my little position. Yeah.
Room changed a little bit, didn't it?
Yeah, dude.
Oh, my. That table's a wee bit overloaded, or is that? Like a little belly thing to it.
It's your fault.
Oh, that's what I should be doing.
So what the hell? I don't understand this.
What's up, bud?
I've never used this before either.
Oh,
Why is it showing 9 millivolts? And I've got it set to
that's
3.
always the trickle it has on these things. Yeah, you got output. What the hell? Are you hooked up? Yeah, you're hooked up. Oh,
You know what? I had it on the other way.
no. You had me confoozled. There you go.
Huh.
Yeah, and I mean, and these are nice too, because you can hit this guy and creep or go, you know what I mean?
Yeah.
I like that.
So you actually have to bump the current a little bit to get it to.
Isn't that just crazy?
I didn't know that.
Because I had that happen back in February, January,
Uh-huh.
and the red light was on, and I'm like, come on, these are brand new.
Right.
And I was monkeying with it, and then boop, and I went, no way. So you got to give it a little trickle for some
I
reason.
guess I should have played around with it before class today.
Ah, I got you. We got this.
All right. Are you guys able to get it to read the voltage that you're trying to output? What's up? Not turning on at all?
Son.
Live. And really all I want you to do is use the power supply to supply voltage and read the voltage on your meter so it matches up. And I'm going to do the same thing with this guy. So I'm reading on the power supply on channel 1. You guys getting it to work or no? Yay, nay? All right. I'm just gonna make sure that my Fluke is reading the same thing, and it is. The 2.99. I'm on channel 1 on, and I can. Well, that's current. Adjust it up. And this power supply will give you up to 32 volts DC and up to 3.2 amps of current. Any issues? Skizzers, I do. Yeah. Oh, you got open.
That's the problem with the digital multimedia. It's not turned on. It's like, oh yeah, stuff on the screen. No. All right, let's do names. Remember Kyle. Tegan. What? Harrison. Caleb. That's a good one. Tegan. Tegan. Jader. Yeah. Yeah. No, it's still something. least didn't blow up.
Did it get in there or no?
Harrison. Agent file. Yeah. You can set the voltage on power supply. Try turning the channel.
Once you played around for a little bit, you got voltage coming out of your power supply, you're reading the same thing on your meter. Go to L1. Next Thursday, we'll go over the board. Fire extinguisher. Right there.
For a second, I thought you didn't know where it was. I was like,
We'll go over it. I don't want anybody to get comfortable with this equipment. I'm not pushing up to a certain amount of voltage and go over that. I'm not gonna be joke around. We probably should put safety glasses on when we're doing this stuff. So we can make sure Thursday, if not.
when would we get up?
Order. I call it. Just call them. We gotta do it first. We can't go down the top. I'm not sure how.
They should be in the little box. See, I have the.
They usually have them here on campus. They don't have them here at campus. If you call them or go in and call them. That's what I'm trying to
they've got the same. All right, if you're done playing, start everything off, log out. I'll see you guys on Thursday. Or anything else I need to get you guys besides that tool list? You got my email address now, so feel free to contact me if you have questions. I'm also, if you're industrial electrical, if you didn't self-enroll, I'm also your advisor. Do you know how to work out? Yeah. This thing. So, how do you know it? I work with her. Okay. I've been holding her up.